So you want to fly. First off, unless you have wings, you'll need a plane. When flying a plane, there are two main forces that act upon the aircraft: lift and weight. As long as the lift is equal to or greater than the weight of the plane, it will remain airborne. To increase, decrease, or maintain a certain altitude, pilots use the lift force equation. But don't let this equation get you down, because in under 3 minutes, you will be a master of the skies. The lift equation determines how much lift an aircraft will produce. Let's break the equation down into 3 parts: the lift coefficient, dynamic energy, and wing surface area. First, let's look at the lift coefficient. The lift coefficient is how much lift a plane will produce at a certain angle of attack. The angle of attack is the angle between the relative airflow and the wing chord. As you can see, the higher your angle of attack, the more lift the plane will produce. However, at a certain angle, called the CL max, the wings will stall and stop producing lift. Next, we will learn how to calculate dynamic energy. First, we will need to calculate the rho, or air density. To find the air density, you will first need to find the pressure altitude. Pressure altitude is equal to the standard pressure, which is 29.92 in inches of mercury. 29.92 minus the current pressure setting times 1,000 plus current elevation. This will give you the pressure altitude. You then plug the pressure altitude into the density altitude equation. The density altitude equation is density altitude equals pressure altitude plus 120 times the outside air temperature minus the international standard atmospheric temperature, which is -2 times the current altitude minus 15. Next, you will need to find your velocity, or true air speed. True air speed equals indicated air speed times the square root of air density at sea level, which is 1.225 kilograms per cubic meter, divided by the true air density, or rho. This will give you your true air speed. Now that you have your rho, or air density, and your velocity, or true air speed, you can calculate your plane's dynamic energy. Next, we will calculate the wing surface area. The wing surface area is determined using geometry. First, determine the shape of the wing, then use the appropriate area equation. The wing surface area is the only constant and does not change mid-flight. If your wing surface area does change mid-flight, you have bigger problems. Now that you have a deep understanding of the lift equation, you're ready to soar to new heights. Congratulations and good luck.